Lesson 2 has an extension. We're going to talk about what happens when we graph proportional relationships. So we just talked about proportions. Remember, for something to be proportional, it's equal. So what happens when we're graphing and they're in a relationship? How to tell? What are those key factors? So first, let's go over some key vocabulary. Constant rate of change. That's a rate that describes how one quantity changes in relation to another quantity. So it's describing the change. You can use the constant rate of change to show that the graph passes through the origin. So constant rate of change, when something's changing at a constant rate, that can help determine or show whether or not it's passing through the origin, which is important here. And then the graph of every proportional relationship is a line through the origin. This is probably the most important sentence on this lesson. Every proportional relationship is going to be a line that passes through the origin. Very important. So the key factors to decide whether a graph is in a proportional relationship is that first, the line must be a straight line with a constant rate of change, meaning it's either constantly increasing or decreasing at a steady rate. So important, it needs to be a straight line. And then the second thing that it has to have is it has to pass through the origin. The origin is that point 0, 0. So it has to go through the origin and it has to be a straight line. Those are our two key factors in determining whether or not the graph is in a proportional relationship. So let's practice. We're going to use a graph to tell whether x and y are in a proportional relationship. So if we're given a table, we're going to graph these points, and then the graph is going to tell us whether or not, yes or no, are they proportional. So when we're graphing, each of these are an ordered pair. We have the ordered pair 2, 6, 4, 8, and 6, 10. So if you wanted to write it as an ordered pair, it's 2, 6, 4, 8, right, our x value, and then it's our y value. So that's important to know, and you might want to write these at the top. So whenever you're looking at a table, an ordered pair is always going to be x and then y. So what we want to do is we want to plot each of those points. So what you might want to remember is that on a graph, and I just gave you, this is quadrant 1, this horizontally, these are our x values, and vertically, that's our y values. So remember, x comes first in your ordered pair, and then it's your y. So when you plot a point, you want to go over and then up. So 2, 6, we'd go over 2 on our x-axis, so 1, 2, I'm just kind of counting, and then up 6. 1, 2, 3, 4, 5, 6, and then put a point where that would go. That's our first ordered pair here. And then you just want to go through and plot the rest. If it helps you, you can label all of these across the bottom and going up if that's going to make it easier for you, or you can just count. Remember, that's 0 in the bottom left-hand corner. That's our origin. That's a very important crossover right there where 0 is. So go ahead and let's plot the rest. Our next point is 4, 8. So I'd go to the right 4 and up 8, and then you should put a point. And then our last one is 6, 10. So I'm going over 6, so 4, 5, this would be 6, if you didn't have it labeled. And then we're going up to 10. So 8, 9, 10 would be here. Once you plot, and be careful when you do that, make sure it's just a point. Once you plot those 3 points from our table, you're going to connect them and draw a line. Now determine so that's connecting them and going up to the right. You can also connect and go down to the left. Now in order for it to be a proportional relationship, it has to be two things. it has to be a straight line and it has to pass through the origin. So take a look at this line we just created. Is it straight? You want to ask yourself. Straight? You should be thinking yes, right? That's a nice straight line, at least as best. Maybe you didn't create the greatest, straightest line, right? But it is straight, or it should be straight. But does it pass through the origin? That's our point 0, 0. Take a look at where 0, 0 is. Would our line cross over that? Remember I highlighted it down here in the corner? Does our graph go through that? No. So if it doesn't have both of these key traits, it has to be straight and go through the origin, then guess what? It is not proportional. So we would say no, because it does not pass through the origin. And now we're going to do the same thing in part B with this table. You're going to take each of your ordered pairs, plot them, and then decide would it be a proportional relationship. I want you to pause the video, graph these, and then press play when you're ready to go. And we'll go over this. So you should have your X. You can label your X and Y if you needed to. But you should have each of these points plotted. Over 1, up 2. That should be there. So check that you have that point. 2, 4. So I go over 2, up 4. Put a point. And then over 3, up 6. And you should have a third point. Remember, once you have all 3 points, you can connect those points as straight and best as you can. And now you need to determine, would it go through the origin if you extend it? Now, you might not be the best at maybe at extending it, or you might kind of take a line and go, whoop, and like curve it, and you don't even know that you're doing it. And you might have done that over here, like, oh, look, it can, right? Well, no. So be careful, okay? A tip that I want to give you is that you could look at your table and it will help you determine whether or not it'll go through the origin. And the way you could do that is look at your X's. What's happening to X every time I move to the right? From 1 to 2 and then 2 to 3. We're adding 1 every time. Do you see that? What's happening to your Y every time? From 2 to 4 and then 4 to 6, we're adding 2. So see how it's constant? So we're adding the same amount of X's and then the same amount of Y's, so that's constant. But now decide, would it bring me back to 0, 0? So what I mean is, as we move to the right, we add 1. So if I were to go to the left, I would take away 1. So what's 1 minus 1? 0. And do the same thing with your Y. If I move to the right, I'm adding 2. So if I were to move to the left in the opposite direction, I'm going to take away 2. So what's 2 minus 2? 0. Do you see how we got to the point 0, 0? Which means our origin would fall on this line, which means it would pass through the origin. So again, ask yourself, is it a straight line? Yes. Does it go through the origin? Yes. So because it satisfies both of those key factors that identify a proportional relationship, then we would say yes, this is proportional. And you could say because it's a straight line and it passes through the origin. All right. Our last example down here, interpreting the graph of a proportional relationship. So interpreting a graph, this is very important. So it says the graph shows that the distance traveled by the Mars rover Curiosity is proportional to the time traveled. So they're telling us that it is proportional, and you could check that. Take a look at this line. Is it a nice straight line? Yes. Does it go through the point 0, 0 or the origin? Yes. So guess what? It is proportional. So what they want you to do is they want you to interpret each plotted point on the graph. Interpret means to explain or to describe. So what do I mean by that? Is you're going to take each ordered pair, right? There's 3 on this line, and you have to interpret or explain what it means for this graph. So the first point, 0, 0. Well, 0 is our X. So what is our x's? What are our x's representing? Take a look at your x. It's representing time in seconds. So what that means is that in 0 seconds, this Curiosity rover travels. So in 0 seconds, it travels. And now let's look at our y. How far does it travel? Because your y is showing the distance in inches. See that? That's our y. So our y is also 0. So in 0 seconds, this rover is going to travel 0 inches, right? If it's not moving any amount of time, then it's not going to be moving any amount of distance or inches. So now we need to do that for each ordered pair. Our next one is 1, 1.5. So let's explain that. Our 1 is our x, which represents time. So in 1 second, and you could be as specific as you want. You could say in 1 second, the rover Curiosity travels, and look at your y now, 1.5 inches. So in 1 second, it travels 1.5 inches. So go ahead and write that. So interpreting means you're just explaining the point in terms of the units given. Now what I want you to do is interpret this last ordered pair, this last point, 3, 4.5. Go ahead and write that down on your paper, 3, 4.5. Go ahead and explain that to me in words. Hopefully you're saying in 3 seconds, it travels 4.5 inches. Go ahead and write that down, and you are correct. So interpreting means to describe in words. So you should have that all written out for all of the points that are there. Remember this last one, you're writing in 3 seconds, it travels 4.5 inches. Perfect. And that is it for this lesson. We'll practice interpreting, graphing, and determining whether